Welcome to another Access Control coaching session, everyone. My name is Cole Nebaker. I am the Training and Events Manager for PDK. And in today's session, we are going to be talking about power management, specifically as it applies to low voltage, and even more specifically as it applies to access control and PDK. So we're going to cover a wide range of topics and definitions, as well as some specifics about PDK power management. So be sure to leave questions as they come to you in the comments. There's about a 30-second delay from my side going into the video. So be sure to leave those questions early, otherwise that 30-second buffer may mean that I miss them, and I would hate that for you. So let's go ahead and get started with power management. So let's begin with a couple of definitions. We're going to talk about voltage and amperage quite a lot. Voltage is a force. The voltage will be the pressure. You can kind of think of this as a water pipe analogy. It's not perfect in every way, but it certainly helps if you're unfamiliar with the terminology. Voltage is going to be the pressure in the pipe, the pressure of the water. Voltage, as it pertains to voltage, is applicable to the electrons, which you can kind of think of as the water molecules in the pipe. So, again, voltage is that force, the pressure that pushes those charged electrons through a conducting loop, such as copper, which is most frequently what we are dealing with. Amperage is the measurement of how fast that water is moving, how fast those electrons are moving. So that is going to be the rate and the speed at which those electrons flow. So both voltage and amperage go hand in hand when we're talking about electricity. To make this easy, we work with a term called wattage, which is very simply just voltage times amperage. So we're going to cover transformers that PDK offers later in this presentation, but you'll notice that I use a term such as 28 watts. For that transformer, and that just simply means that we have a 14 volt 2 amp power supply, which we multiply together to get that 28 watts. Additionally, some terms we need to know will be resistance or impedance. Since we're working largely with DC power when it comes to our product, I'm going to focus on resistance, but that's going to be the force that opposes the flow of currents through the conductor. That's measured in ohms. We also need to work with line loss. So line loss will be how much energy is lost while the electricity is traveling through a conductor. And this can be lost in a couple of ways, but most commonly it's lost as heat. Finally, wire gauge is an important consideration, but we're going to cover that when we get to a graph of how it specifically relates to the voltage and amperage and distance of a line run. Wire gauge is measured in AWG, which is American Wire Gauge. It's super counterintuitive, so we're going to cover how the numbers go backwards for some reason, some decision made a long time before I was born. So wire gauge is going to be the thickness of the wire measured by its diameter. All right, now going into the next piece, we're going to cover the Altronics eFlow and the PDK transformer. These are the two primary methods that we use to power PDK boards. So the Altronics power supply is one that is built into our Red 8 and our Red Max. We use the eFlow 102NB to take high voltage and convert it down to low voltage. It has a few other features built into it as well. So you can see right there, the input is 120 volts, about 3.5 amps, and the output is 12 volts and 10 amps. So you can see it's just transforming a high voltage down into a usable low voltage for PDK. So that 12 volts and 10 amps means we have, with an 8-door controller, a little over an amp of power per port. Now additionally, these eFlow boards have a built-in fire disconnect and battery terminal, which you can find the schematics for in their documentation. The fire relays there on the left, one of those gray connectors on the bottom, and then the battery terminal is the other green connector on the bottom of the board. That just means that you can charge up and discharge a battery in case you ever lose primary power. The PDK transformer is a little simpler. It doesn't have all the built-in bells and whistles, but it's very useful for PDK's smaller boards. So if we're only dealing with one PDK board, all of them come included with one of those PDK transformers. And they come in one of two sizes. They're either going to be this one, which is the 28 watt one that I mentioned at the beginning. It's the 14 volts and 2 amps, and that's the one you see on the screen. Or it will come in a 12 volt 5 amp, which is 60 watts. So it's either going to be a 28 watt or a 60 watt transformer. It's very simple. You just tie your wires into those screws on the bottom, and then you plug it into a wall socket. And it's taking that high voltage out of your wall socket and converting it down to low voltage for your PDK controllers. Now you also have PoE as a method to deliver power to your controller. So the PoE module looks just like that. It goes on a set of pins on any PDK board. So I want to emphasize that even though this chart down below only shows red 1, red 2, red 4, this is also applicable to the aux 8. And it'll have the same numbers as the red 4. I just want to mention that before I get too far into this. So when you plug it in onto a board, when you plug it into the pins on the board, it is going to siphon as much power as you provide to it. So you have 3 PoEs that you can, or 3 PoE standards that you can use. So you can use PoE, PoE Plus, or PoE Plus Plus. And whichever switch you use and whatever you configure that port to utilize is what the board will take in. So we are working with 11 watts for across the board with PoE. If we use a PoE switch, we will have 11 watts and about 0.8 amps per board. So regardless of whether you're using a red 1, red 2, or red 4, you will get that 0.8 amps. That's kind of low, I would say, for the red 2 and red 4. Generally, I would say if you're unsure of what PoE standard to use, I would say probably use PoE for your red 1, your PoE Plus for your red 2, and your PoE Plus Plus for your red 4 and aux 8. That said, if we go into the PoE Plus side of things, we have 24 watts. And that gives us about 1.7 amps across the board. So roughly an amp per port on a red 2. And then we have our PoE Plus Plus, which gives us a substantial jump. You'll notice that it's 27 watts for both red 1 and red 2, which is pretty average for what you typically need on either of those. But for the red 4, it jumps up significantly to almost 50 watts. So that is designed to give you 3.5 amps of power across the entirety of the red 4. And admittedly, that is still a little under the 1 amp per port, but it should be more than sufficient for your readers, your peripherals, and other things plugged into your red 4 or your aux 8 controller boards. Now going into wire gauges, this is getting the power from the controller, which we are powering in one of those 3 ways, PoE, the transformer, or the Altronics board. This is getting the power from that board out to the lock or the reader or whatever we need to power up. So we have to consider our wire gauge, and this is dependent on a few factors such as the voltage you're using, the amperage you're using, and the distance you are running. Now fortunately, to make it nice and easy for us, lots of manufacturers post in their documentation how far you can go at what voltages and how much amperage you're going to need for that. Now when I mentioned that the AWG standard is somewhat confusing. For those of you in the industry, you're probably very familiar with this. It's not confusing anymore. For those of you who haven't been in the industry a long time, super counterintuitive, right? You have 24, 22, 18, 16, 14, 12, 10 gauge. And you'll notice by the diagram on the right, the smaller the number, the bigger the wire gets. So 24 gauge is very small, whereas something like a 14 gauge is fairly substantial. Now generally we're going to be working with something more like 18 to 24 gauge. However, the thinner the wire gets, the more prone it is to line loss, which is the voltage interference where it loses voltage over distance. So because of that, we need to go with thicker wiring the longer the distances that we're going. Now this chart on the next page is going to show you what kind of distances you may be dealing with. So for example, we have 12 versus 24. The 12 is the white lines going across, and the 24 volts is the gray lines going across. Let's take a very average scenario here. Nothing too offensive. We'll go 300 feet and we'll go 400 milliamps. So if we go down from 300 feet and across from 400 milliamps, you can see we're dealing with either 18 gauge or 20 gauge wiring. You'll notice that it's different for the 12 versus the 24 volts. And the reason for that is because 24 volts has more pressure. It can get the electrons further along in a pipe than 12 volts can. So we can go with thinner wiring for the 24 volts. And that's a big advantage if you're going fairly long distances. Now, it's worth noting that PDK's boards only output 24 volts, or I'm sorry, 24 volts, 12 volts. Got my voltages mixed up there. So we can only output 12 volts. That means that if you were running 300 feet with 400 milliamps, say a strike, for example, you're going to need 18 gauge wire. You can see it gets fairly thick the further we get up, even for 24 volts. So at 1,000 feet and 1 amp, let's say we are really getting crazy here and running a really beefy mag lock or an electrified crash bar 1,000 feet away. We're getting all the way up to 8 gauge wire for 12 volts and 10 gauge for 24 volts. So at some point it might make sense to move everything a little bit closer to the door. But you can use this diagram as a rough reference for what kind of wiring you're going to need based off of the voltage, the amperage, and the distance. I had a train of thought and I've lost it, so we'll just keep going. So let's get into all of the PDK devices and cover what kind of voltages and amperages we need to put in and how much we will get out. So you can put 12 to 24 volts DC into any PDK device, but I want to note with that even if you put 24 volts DC into the PDK controller, you're still only going to get 12 out. So if you are trying to use a 24 volts piece of equipment, you're going to have to use a third-party power supply, and you're going to have to tie it through PDK as a dry contact. So you can see in the bottom right there, we have 12 to 24 volts DC, 2 amp input. That's the provided transformer that we offer is 14 volts and 2 amps with the cloud node. And it requires roughly 200 milliamps at idle. So you can use this to calculate how much backup battery you have and how much leeway you have for powering devices off of the controller. You have 200 milliamps at idle, maybe you have 200 milliamps for a reader, maybe you have, I don't know, 50 to 75 milliamps for a Rex device. You can very easily from there determine how much time you would have with a backup battery attached to the cloud node, or how much leeway you have to plug in, say, a strike or a mag lock. Moving into the single door controller, this is going to be almost identical, with one exception. It doesn't require as much amperage to run because it is simply not using the onboard database that the cloud node is. So instead of 200 milliamps at idle, it's only using 35. That's kind of the interesting thing with the Red 1, the Red 2, and the Red 4, and the aux 8. I always forget to include the aux 8. They all use the same amperage at idle. They are all using the same fundamental components to run at that idle speed. So they are all using 35 milliamps at idle. That makes it pretty easy across the board. But with the Red 1, it's again 12 to 24 volts DC input and 2 amps. We include that transformer, that wall plug transformer that provides the 14 volts and the 2 amps. The same goes for the Red 2. It is also using that 14 volt 2 amp input. So generally what you can expect from a PDK controller is about an amp of power per port. Moving on to the Red 4, this is going to be utilizing a different transformer that comes with it, unless you, of course, choose to power it via your own method. Instead of the 14 volt 2 amp transformer, it comes with a 12 volt 5 amp transformer. It comes with that beefier 60 watt transformer. This, though, does also require 35 milliamps at idle, so nothing changes there. It's just that it's capable of powering more stuff. So you have 5 amps across 4 ports to work with, so about 1.25 amps per port. I've neglected to mention on the red 1 and red 2, and I'll mention it on this one, you can use the PoE module on any one of these to provide the power as an alternative. And you know, something interesting that I actually learned the other day, you can use PoE as a primary source of power, but still plug in the transformer as a backup source of power. So you can have PoE and the 2-pin connector connected at the same time. So that's a good way to have built-in redundancy for the power side of things. And then, of course, you have the battery terminals that are connected to all of these. So you can use an 8 amp hour backup battery inside of this enclosure, or you can tie it into a different enclosure sitting next to it with more backup. Now, getting into the red 8, this is where things change a little bit because we have the Altronics eFlow in there. So instead of being a plug that just plugs into a wall outlet, this one is tying directly into the high voltage line. So you tie it into that green portion in the top left-hand corner of that board into the high voltage, the 120 volts. Then you have your DC output, which is on the bottom, and that is tying into both of those red 4s. So the red 8 is just 2 red 4 boards, which both require 35 milliamps at idle. So 35 times 2 is 70 milliamps, so you only need 70 milliamps to power both of those. You have the 10 amps of potential power from the Altronics eFlow board, which again gives you just a little over an amp of power per port on each of those. This one does have more space in the bottom of the enclosure. It's actually mislabeled on this page. It's, instead of an 8 amp hour backup battery, it's a 12 amp hour backup battery. And you can actually fit 2 in there. So if you want to tie those 2 batteries together, you can potentially get up to 24 amp hours. And then finally, that leads us into the red max, which is going to be the 2 Altronics eFlows. And pretty self-explanatorily, is that a word, explanatorily? That's a new word. I'm going to deem that a new word. We have 2 Altronics eFlows, which give us a total of 20 amps of power. Now, you'll notice that it says 70 milliamps at idle, but it shows 6 boards in this picture. The reason for that is when you first purchase the Red Max, it actually only comes with 2 boards. It's effectively a Red 8 with 2 Altronics power supplies. You populate the rest as you go. So potentially, if you have 6 boards in here, it'll be 200 and, let's see if my math is good, 210 milliamps of idle power. So you've got a ton of leeway with that 20 amps of power available to you. And you can, likewise with the Red 8, you can also fit 12 amp hour backup batteries inside of this enclosure. I believe it's 3 that you can fit in the bottom of this enclosure. So you can tie them all together, you can tie them into just one Altronics board, whatever you choose there. So this is anywhere from 8 to 24 doors. Of course, if you prefer to do PoE on this, you could just run a PoE, what's the term I'm looking for? The PoE module onto each of these boards and just tie each of these boards into a PoE switch. For our readers, we've now covered all of the power to our controllers, and we've covered how we're going to get the power down to the locks and the peripherals, but now we need to cover actually how much those readers and peripherals take. So this is just a rough reference guide. There's specific data sheets on each of these on the website. But our red readers, for instance, take anywhere from 5 to 16 volts DC, and roughly about 100 to 200 milliamps of power. And it depends on which model of the red reader you have and what technologies you're using inside of that. The Bluetooth technology in particular takes a fair bit more amperage. You can see that by the Touch I/O right next door to this. It uses 5.5 to 16 volts DC, and it takes anywhere from 100 to 225 milliamps. So that is a fairly significant amount of power for a reader. Again, it just comes down to the technology built into it, so make sure you're prepared with your amperage calculations accordingly. Otherwise, you will exceed the limit of what is available through the board and you may trip the circuit. Our rugged readers are a smaller range of voltage, and you can see a very small amount of power is actually required. We have 11 to 13-ish volts DC, and our amperage is 45 milliamps, so basically negligible, basically the equivalent of running a PDK board all by itself. And then the standard readers are exclusively 12 volts DC and 30 milliamps. So PDK boards output 12 volts out of the reader port. So if you are going to use any of these, they're just going to, by default, use the 12 volts. If you also want to power your locking hardware or your peripherals off the PDK board, you can simply just tie it into the positive of the reader port as well. So makes it pretty easy across the board. Again, PDK boards can only output 12 volts. So if you're going to use anything 24 volts, you will need an external power supply, and you'll just tie it through the PDK relay as a dry contact. All right. Now, worth noting, you will want to make sure that you are using a, that's my symbol for him to move to the next slide, in case you caught that. In case you are going to be cutting it close with power, you'll also need to consider things like inrush current. So sometimes when you plug things in, it takes a certain amount of current to get it up and running, and that can sometimes exceed your budget of power available to you. So let's say that we have 1 amp of power available to us, and we are utilizing 950 milliamps. Well, it might seem like we're good. We're close, but we're still good. But we didn't really consider the 50 or 100 milliamp inrush current that the door strike requires. So as soon as we power the PDK board on, it is going to exceed the threshold of what is available to that board, and it is going to go into a reboot loop, trip the circuit, you name it, whatever it is, it's not going to be fun. So keep that in mind, and a lot of what I saw in support too is that sometimes people plug in, for example, the Touch I/O, and they say, oh, well, it's only going to take, say, 75 to 100 milliamps, not realizing that it can potentially take up to 225 milliamps. And so they have something really power intensive tied into the same port as that Touch I/O, and all of a sudden the PDK board's not powering on because it keeps exceeding the threshold, exceeding the limit. So it's very important to add all of your devices together. The PDK boards, don't forget the PDK board. Even though it's 35 milliamps, that 35 milliamps can make or break something. Your readers, your locking hardware, your peripherals, even include the battery. Make sure you have a little bit of leeway for charging up the backup battery. As long as you maintain yourself underneath the limit, including that inrush current, you should be okay. I didn't have a slide to that, but in hindsight, I probably should have thrown something about that in there. Anyways, you just get a look at my face while I blab on about that. So if there are any questions, be sure to leave them in the comments right now. Again, there's a 30-second delay, so I'm going to go on a little bit of a rant here to give you some time to compose your questions and put them in the YouTube comments. But as a side note, we do these training sessions once a month. So be sure to tune in. It's the first Tuesday of every month. It makes it very easy to remember. If I ever forget that we've started a new month, I very quickly remember because I'm thrown into one of these sessions. So we always cover really topics that we get a lot of requests for, or maybe that our support team has heard a lot of in that month. So these coaching sessions are going to be really valuable for you refining those skills that maybe you're not as comfortable with as you are with other things. As an example of this, we just picked a topic for, I want to say it's September's coaching session, I think it is. It's ADA buttons, which personally I am super uncomfortable with. So I'm going to be studying hard before this training session. But that's a prime example of what we're trying to do. And we're trying to find topics that people are not as familiar with and get them educated up on it. So I think we have a question, a question here. It's not really a question, more of a statement. Tyler says, there is no good or evil, only power, and those too weak that seek it. Lord Voldemort. I think that is profound. Thank you, Tyler. I don't see any other questions coming through. If you're watching this after the fact and you have follow-up questions, you're not watching this live, reach out to the sales team and they can help you out, or reach out to the support team. Either way is fine. You can reach out to sales at prodakey.com, and you can reach support either by calling in 801-317-8802 option 2, or you can email support@prodakey.com. Our knowledge base is another phenomenal resource. That is just support.pdk.io, and that has a lot of the material that we cover here as well. So, thank you for joining in. I always appreciate all of you jumping in, and for any questions we might receive, keep us posted if there's a topic that you want to hear next, and we will see you next month.